Модернізація конструкції сепаратора пари у багатоступеневому аквадистиляторі продуктивністю за чистою парою 500 кг за годину. Керівник доцент Чепелюк Олена Олександрівна. Будь ласка, Олексій. Please.
Greetings to the head and members of examining commission and colleagues. Do you hear me well? Yes? Not?
Yes, please.
Okay.
Yes.
I'll start with actuality. One of the most vulnerable places in aqua distillers are drop catchers. The efficiency of capturing water pharmaceutical production. The capture of water drops during aqua distillation reduces the amount of harmful substances, including pyrogens, which pose a danger to human health. The study of drop catchers designs is important to reduce the risk of getting substances into medicines that can cause unexpected side reactions. Of steam drop. The object of the study is steam. The purpose of the study is to create a drop catcher that achieves high efficiency of catching water drops in steam in the process of aqua distillation. Consider the drawing of the drop catcher. It consists of 5 partitions, of which 3 partition A and 2 partition B. They are arranged in staggered sequences with openings overlapping with the partition of another structure. That is, partition A overlaps the openings of partition B and vice versa. It's a pretty simple idea to me, but we'll see later that sometimes simple ideas create great results. The model is built according to the principle of concentric circles. The distance between the openings is 15 millimeters. The openings themselves are also 15. B differ in that they are built in reverse, except for the central holders. After the model was completed, the simulation was carried out in SolidWorks Flow. Specified the inlet boundary conditions, which was the total pressure, at which I set the steam temperature of 434 Kelvin or 161 Celsius. For the boundary condition at the outlet, I set the mass flow to 0.1389 kg per second or 500 kg per hour. You can see the vectors of the flow and its speed in different sections of the research part of the aqua distiller. It can be confirmed that the motion simulation is working correctly, as the motion of the steam is directed upwards, changing directions, and has turbulent locations. You can see the change of velocity along the plane and the flow vectors. The initial velocity is 0.5 to 1.25 meter per second, where the flow has not yet encountered the first partition. And in the center, the speed is 0 to 0.5 meter per second, since there is an obstacle along the strained path, so the flow slows down. The speed gradually decreased with each partition, and after passing all partitions, the speed gradually increased. Here we can see the temperature change on the plane and the vectors of heat movement. The highest temperature can be observed in the center in front of the first partition. This may be due to the fact that the steam moves slowly in this place and the pressure increased. In this area, the temperature reached 510 to 600 Kelvin, or 237 to 327 Celsius. Behind the first partition in the center is the lowest temperature, 372 to 418 Kelvin, or 99 to 145 Celsius. This may be due to the least amount of steam in this area and due to the heat exchange with the first partition. I created control points in various sketches in order to construct the 3D line to approximate the steam flow. Using the straight line, which is usually used for construction graphs, the result would not be correct because they would show values where there's no steam, that is in the partitions themselves and immediately behind the partition, where steam does not appear after touching a partition. The graph on the left shows that the steam flow rate decreased when approaching the first partition due to a significant amount of steam hitting it and changing vectors of movement, which slows down the steam that was moving towards the opening. The speed between the partition is determined by the pressure difference, and after leaving at the drop catcher, the speed stabilized. The graph on the right shows that the temperature of the steam decreased when approaching the first partition, and then remains at the same level. This can be explained by the heat exchange between the steam and the partitions. On the graph of the distribution of the mass fraction of condensate can be seen that approaching the first partition, the condensate becomes larger. The sharp increase in the mass fraction of condensate from 0 to 0.11. It was why be important to make part of aqua distillation mass fraction of condensate decreased. This can be explained by the fact that the condensate it retained on the walls, and further passages of the partitions reduce the mass fraction of condensate. Also, it can be seen that the mass fraction of condensate decreased to 0 at the length of approximately 300 to 310 millimeters, and therefore after passing through the third partition, the steam is cleaned of the most the impurities. And conclusion. Since the effectiveness of the drop catcher is determined by the mass fraction of condensate, the study showed that the created model of the drop catcher, 3 partitions are enough to catch condensate. And therefore, it can be concluded that it is possible to reduce the number of partitions, having the same efficiency and at the same time reduce the length of the drop catcher. Each partition has a thickness of 10 millimeters and distance between the partition is 40 millimeters. So the length of the drop catcher with 3 partitions will be 110 millimeters, which is 100 millimeters less than the length of the drop catcher installed in this aqua distiller. That is, the length of the drop catcher can be reduced by almost half by 47.6% using this model, at the same time achieves high efficiency. Thank you for attention.
Thank you. And you? Будь
Thank you,
ласка,
Олексій.
питання.
Did you have opportunity also to check a model, working model of drop catcher? Did you create some?
No, I just make a model in SolidWorks, but I can't make the this drop catcher. It like need some money, and then I need to use this model in some machine. But I don't think that I can put my model into the machine on my job.
And second question, maybe I just missed in your presentation, how did you measure efficiency of drop catcher?
You mean this?
Yes, are you measuring by condensate separation?
When I used the flow simulation, it can be choose which measurement I need. Understand. I think it's like percent of all mass of steam. It's condensate.
Thank you.
Олексій Олександрович, прошу.
Thank you. Олексій,
I know you work at the Darnica pharmaceutical factory, and I have some questions. The first, do you work with this equipment from your presentation? Another, what is your responsibility there at the Darnica pharmaceutical plant? And did you present the result for your colleagues? Are they interested?
First question. I'm not quite working with this machine. I'm like supervise the terms when we need to inspect and test this machine. It's like every year we need to inspect and test this machine and each other like tank under pressure. And also I organize a meeting with an expert who should came and make his own inspection and test for serviceability of this machine. So I don't exploitate or repair. I just like watch of safety of this working process.
Understand.
About
your colleagues, did you present the results?
I present. I show this model, but for using this model in reality, need like more research and be 100 sure that this model will good efficiency in our case. And also it's need to make a budget. We make budget like on next year in the December. So we need to make budget for this and to make work. So it's not like I show and then we in 2 weeks start work at this. But they think we can look at this variant. Maybe not. We'll use this.
Well, thank you. Success. Дякую.
Так, thank you. Олексій, sorry for my poor English. Simple question. What is scientific novelty of your results?
That we have 5 partition and the efficiency results graph of efficiency of this drop catcher shows that 3 partition are enough. So we can make less lengths of this drop catcher and at the same time reach high efficiency. So in aqua distiller, we don't need like 200.
Sorry, on slide.
You see the mouse?
Yes.
Okay. As we see about efficiency of this drop catcher, it was high efficiency on 300 millimeters. So we can use only 3 partition. It on 100 millimeter less length. So we can make better construction, I think. In aqua distiller, we have drop catcher with 210 millimeter length, and my model shows that high efficiency can reach with only 110 millimeters.
Thank you for your reply. Next question. No question.
Юрій Юрійович, будь ласка, рецензію.
Так, рецензія тут у нас буде державною мовою. Рецензія на роботу Олексія Юрійовича надійшла від Токарчука Сергія Володимировича. Серед недоліків відзначено: в пояснювальній записці не наведено порівняльний аналіз існуючих пристроїв для відділення краплин рідини із пари, на кресленні загального виду установки не показані збірники для води очищеної, і останнє з роботи незрозуміло, як виконано теплове ізолювання апаратів установки. З зауваженнями погоджуєтесь?
Zgoda. Yes.
Yes. Так, добре, дякуємо за вичерпну відповідь.